Okay guys, take two. It's had fun seeing the clear blue skies the second time around. Well, I went ahead and shut off one of the devices here that may be causing the dropouts, and I'm getting 0 dropped frames, so I think we're looking much better here. I didn't want to get into that stream until I was sure that the data was flowing through to YouTube, so I think we're good. We'll start out with tonight with the 250 millibar chart. This is going to be up at about 34,000 feet. And let me take a look, get this centered here. And this kind of provides us with a master solution to what's happening across the U.S. this evening. I mean, if you're going to look at maybe 2 or 3 charts, pick out that 250 or 300 millibar chart. So to read this chart, you can see we've got kind of a series of waves that look like this. Okay. There's a couple of different kinds of waves that we look for. One is kind of like the broad scale wave picture. So, for example, see this area right here where it's kind of lifting northward? That's going to be a long wave ridge, and that's running from about Albuquerque up to Manitoba. Looks like there's another very broad scale ridge out in the Pacific and another out in the Atlantic. So this is pretty similar to what we had yesterday. And then we have smaller scale waves. That would be this thing right here. And this one way up, well, that's way off the top of the map. Let me move that here. Yeah, you see that trough up there and this one here. Those are some medium wave troughs, and they're all part of this long wave trough that covers much of the Atlantic. And there's a little ridge going through that. So anyway, the polar front jet coming on shore around Portland, Oregon, coming up to Alberta, and rounding the top of that ridge and coming back in over Wisconsin out to Pennsylvania. So that is the polar front jet. Where's the subtropical jet? Well, I'm not 100% sure we have one. I didn't see one yesterday, but I do see this one jet segment running from about Dallas out to Jackson and Atlanta and out to Charleston. So that could be a subtropical segment. Also there in Tallahassee and in Jacksonville. So how do we make the final determination whether this is a polar front jet or a subtropical jet? Easiest solution is to go down to 500 millibars and look at the wind pattern. So the winds do look a little bit strong in that area. So I think that this is probably a weak polar front jet segment, because typically underneath a subtropical jet we don't see very strong winds at all. And also this is kind of a cyclonic jet stream segment. Subtropical jets have a very strong affinity for anticyclonic segments, so we would expect to find it maybe like that. And I think a very common location this time of year would be around maybe Tucson and then down into Corpus Christi like that, but nothing like that going on. All right, 700 millibar chart showing the capping. Got some very warm temperatures out in the Rockies. 12 Celsius all the way from Dodge City up to North Platte and just north of Rapid City. So that's keeping things pretty well suppressed on the high plains. It's very hard to get storms going when it's 60 degrees up at 10,000 feet. The weaker capping is out over the Midwest, Arkansas, Missouri. Temperature's only about 7 degrees Celsius in that area. And up to the north, we're looking for maybe some thunderstorms in the North Dakota area tonight. We'll go to the radar and pull that up. And there are some chasers waiting in the Bismarck area for initiation. This is an upper-level wave, or the manifestation of the upper-level wave, moving across western North Dakota. So it's kind of heading that way right there. And if I animate this, you can kind of see what's going on there. So very fast motion in that cloud field. This is moving about 50 knots. So that's embedded in the mid and upper level flow. And then down in the lower levels, you can see what looks like boundaries there around the Bismarck area. So you see those surging southward. Now typically that would indicate maybe some outflow air that's going to ruin the chances of storms, but actually this air up in here is actually very moist. And let's look at that surface chart and see what it looks like. I think I'll start with a small scale here. There we go, there's the Dakotas. And we do see that northerly flow in that area, but what we're kind of watching is this little region right here from about Jamestown up to north of Bismarck. So we got 82 to 84 temperatures over a 62 to 63 dew point. So this is certainly supportive of severe storms, and we're expecting some of this to comprise the inflow for anything that gets going in this area. So what we're looking for, maybe in a couple of hours, storms forming in that area right there, northwest of Bismarck, and possibly a few rogue cells out around Jamestown. There's a possibility they could be tornadic, and let me show you why. I don't know how many of you have ever used the velocity in the clear air mode. We're just looking at the surroundings. Let me switch that over to velocity. And we're not talking about finding couplets like up in that area or out here. We're talking about right at the radar site, what the patterns are like. And one thing that'll really help you is to zoom in and go up to a higher tilt, 4.4. And this will show you the wind structure right there at Bismarck. And what we look for is the zero line, and that's going to be this little white line between the red and the green. So let me draw that zero line out. That zero line is important because that represents where the wind flow is likely perpendicular to the radar site. So at this spot right here over the town of Mandan, it's very likely, well, the radar is right there, so it's either going that way or it's going that way. One of the two. So which way would that be? Let me redraw everything. So the greens, those are always inbound. See that up here, and then down on the other side, down here in this red, that's going to be the outbound velocities from the radar. So we're going from north to south. So that's going to be a motion at that town of Mandan out of the northeast. So let me go ahead and draw the rest. These are the little wind vectors. So I'm going to draw these out for you. There's a couple right there. And this is significant for thunderstorm forecasting because if you consider that when you go away from the radar site outward, any direction, you're going up in the atmosphere higher and higher. So let me draw this in yellow, what I'm talking about. See this little circle that I'm drawing around the radar? That's about 1.5 kilometers up. And then this inner circle, that's pretty close to zero. So we've got directional turning with height. So near the ground, the winds are out of the north-northeast, and then up at 1.5 kilometers, it's out of the east-northeast. So there's a little bit of curvature in there, a little bit of turning, directional turning, and that helps give us curvature in the hodograph. That's basically streamwise vorticity, which can translate to helicity and help rotate the updraft. So with this air mass being kind of moist, there is the possibility for rotating storms over the next 3 to 4 hours. So yeah, keep an eye on that curvature. When you see that S shape with the zero line on the radar, that indicates good shear, good directional shear. And when it's straight out like that, that means there's no directional shear. Okay, that little lesson, that's over there. Let's head back into tonight's patterns. And we're going to start out with the large-scale picture to see what's happening. And let me check on the stream. Zero drop frames. Okay, we fixed it. All right, yeah, okay. So the U.S., we've got moisture down in Louisiana and Texas, and that's finally advecting north into central Kansas, and parts of it making it up into the Dakotas. In western North Dakota, Wyoming, and the Salt Lake City area, we've got a cold front. So that's helping to generate some of that storm activity, and also the upper level dynamics across Montana, moving across that threat area in North Dakota. Okay, the moisture is kind of sparse, except down there in Texas, and this is another way we can look at the boundaries in moisture. This is moisture in green and yellow shading, and potential temperature, the dashed lines, which is basically your isotherms. corrected to around sea level. So we can definitely pick out that front. There it is right there. Keep that on the warm side of the gradient, and I'm talking about that gradient right there. That's the cold air, and the cold air is centered up there around Miles City and Glasgow. And then we can pick out the warm front segment across northeastern South Dakota right there. So just with that little product right there, we can pick out where the frontal systems are. And that can be important because we can see sometimes mesolows developing along these boundaries, especially along the cold front, which is in close proximity to the incoming upper level energy. So we were looking at the possibility of that, maybe a little mesolow developing along that boundary, but the patterns aloft are moving a little bit too fast and too late to really get that going. So we're expecting maybe a little interaction with the moisture there in North Dakota, a little window of severe weather around dusk, and then it should turn into kind of a disorganized, outflow-driven system and move into Minnesota later. Other boundaries on the plains, yeah, we can go down into Colorado and Kansas, and you can see some bad data here. And I'm using digital atmosphere, and that's pretty easy to fix. You just drag over the offending station, and we pick quality control, and we get this little panel here. And what's causing that temperature to be so crazy? We'll kind of flip through the data in that little section, and there it is right there. They're reporting a temperature of minus 17 Celsius, so we can delete that. And there's a couple of those bad reports in there. And then when we go in and replot the fields, it will get rid of that problem there. So there it is. Colorado, warmer air located there over the Rockies, where we've got the very strong heating in that area, and the potential temperature actually drops as you go eastward. Let me center this. I know this is kind of off center. There we go. So there's a potential temperature field, and basically the temperatures are very similar between Colorado and Missouri, but the elevations are lower in Missouri. And when you take this 80 to 90 degree air in Colorado and bring that down from about 6,000 down to sea level, that's going to warm adiabatically pretty significantly. It's about 5.5 degrees Fahrenheit every 1,000 feet. So you're going to get a good 30 degrees of warming there. So that brings the temperature up to 323 Kelvin, which is going to be about 120 Fahrenheit. So that's definitely some very warm air in that region. And interestingly, as you go to the Great Basin area, we can pick out that front. Looks like it's running right through that area here, just south of Salt Lake City, south of Ogden, and right around the Elko area. So I think we might have something like that going on there, and maybe linking up with this other front up to the north. So it's kind of a complex structure. So these are actually some very useful products. Potential temperature, you can really pick out those fronts, whereas if you just take the raw plots in isobars, it's not really quite so obvious. Okay, so if you take this and just look at the plots, yeah, you can see winds coming together, a little bit cooler up in this area, but the potential temperature gradients will help you out quite a bit. And that's an example of how we use it. Okay, thickness and isobars. There's how things look this evening. We can pick out that front there in North Dakota up to Gillette, Wyoming. Warm front right there. And that boundary down in Salt Lake City, Nevada, doesn't show up quite as well. We do see 3 thickness lines like that, and we could probably justify placing a cold front right in there, but we do need that little help there with the surface chart to get that all connected. So that's basically the frontal systems right there in the mountainous terrain. Not a whole lot going on in the East Coast. Little trough there across New York, New Jersey, and then out across the southeast, very weak flow. Even the Bermuda High cannot really get things going very well. Just a very, very light south flow in that area. All right, let's see what else is going on. Let's take a look at the upper level patterns, and we'll look at the dynamics. We'll have to get that one set up for you guys. Oh, no, it's already set up. Okay. Okay, here's the NAM for about right now. And let me back this up about 6 hours so you can kind of see what's been going on. And you can see that upper level trough there around Boise and around Great Falls. So that's moving eastward during the day, and that brings us to the current time. Looks like it's right there in Montana, and all the lift is moving into North Dakota. So this is around the north side of this ridge that's poking up there into Canada. And looks like another short wave coming on shore there in California. I don't know if Ron Chalfant is seeing any weather out in his area, but that wave is coming inland, and looks like by tomorrow it's going to be moving into the Nevada area and then up into Idaho. So I would probably be looking at an increase in thunderstorm activity right in that area. So that's how you can use the upper level charts. Some very good information where you have enhanced lift taking place. Okay, for tomorrow, it looks like that ridge is building in. See that 588 contour? Look at that. It's moving north into Kansas. And let's see what happens going into Thursday. That ridge is really digging in there. High pressure across East Texas. And the ridge axis running about like that right there. So most of the systems are moving northwest from California into Wyoming, Montana, and then going around the top of that ridge. So that high effectively keeps the systems away. Okay, this would probably be a good time to move over to the satellite. And I don't quite have those all set up, so I do have this one visible image. And you can see some thunderstorms going up there in northwestern South Dakota. Some good thunderstorms there around Childress, up to about Wellington, Texas. And we can take a look at a couple of them. Let me bring up the localized sectors. Yeah, we'll use this one here just off the Cap Rock. Some pretty good anvils in that area. Let me back that up. That's probably a little bit too zoomed in. There we go. That'll show us a little bit more. Some very long shadows from those towers, all the way from south of Abilene all the way to Houston. That's about 300 miles. Very long shadow. And let's back that up a little bit and see how things developed. Let's back that up even more. Let me have it skip every other frame. Let's do that. Okay, much better. This is how things looked earlier today. Okay, so clear skies across Texas. Without any boundaries, it's very hard to see where things are going to focus exactly, but there's the Cap Rock right there. That's some very steep terrain. Starts out around Snyder and Post and extends all the way up towards Memphis, Texas. And then out in this area right here, this is all very, very flat farmland. They grow a lot of cotton and watermelons, stuff like that in that area. Maybe some wheat. I don't know if it can support wheat or not. I'm not really a big agriculture expert. Anyway, let's see what happens as the afternoon goes on. Looks like some higher cumulus developing up north around Amarillo to west of Lubbock. And there goes our first thunderstorms up there around the Memphis area. So if you're out there chasing, it's probably a safe bet to head directly towards those. Then going further into about 4 to 5 p.m., numerous storms going up. Basically, they're developing where we have the highest temperatures and the best moisture. And then they start moving off the Cap Rock. And you can see the overshoots right there just west of Childress. So I would expect those to move maybe down Highway 287, maybe towards Knox City for a couple of hours. And I'm not sure if we have the support to keep those going tonight. Probably not. since we're underneath that ridge. And where else can we look at? I guess we'll look at the North Dakota region. And there's the current satellite image. One very good cell right there, just northwest of Sturgis. And going back earlier, big ridge parked over the plains. You can see all that upper level energy coming over the ridge right up to the north. However, that one good wave comes out of Montana. There it is around about 5 p.m. And now it's approaching North Dakota. So things are starting to get kind of stormy on that area. All right, let me take a look at chat, see how things are faring. All right, Carl Berghoff, welcome to the webcast. Sue M., David Lombard and Mamel, 82/59. Erica Baker there in Kansas, 86/67. Shirley Keast, 57 in Michigan. It's still cold up there. Jack Benner, 102 degrees there in Las Vegas. Very warm in that region. Fun with Tech is with us, and Fred Reamer, Alexi Pinkson-Walsh, Willie Greenway there in Georgia joining us. Fred Reamer, Coffeyville and Hailstones. Yeah, for a while, Coffeyville, Kansas had the largest hailstone record, I think up to around 2003. And I'm guessing the diameter was somewhere around maybe, I can't remember the number, 5 to 8 inches, somewhere in there. And then a very strong storm in Nebraska claimed the record, and that cell was in the Grand Island area. And I believe it was eclipsed one more time, and I kind of lost track of how that went down. Justin Pulliam, hello, and Christian Flock there in Yukon, Oklahoma, but now West Cliff, Colorado, hiking. Sounds like fun there. Brian Toomey is reporting evening thunderstorms in South Florida. Yeah, let's check that out. Of course, it's nighttime there in Florida, but we can run that back and see how things looked earlier. Picked up a pretty good westerly flow there. Lots of storms in the Tampa and Lake Okeechobee area, and then moving that forward, they move off the East Coast out around the Vero Beach area, and more storms going up, I guess maybe just north of West Palm Beach. And I can see a very good outflow boundary right there. If I can zoom that in just a little bit more, I might be able to bring that out a little bit. Yeah, you really got to get these high resolution sectors to really see those outflow features. So here we go. This is a little bit earlier. And then, yeah. See that right there? That's that outflow boundary surging southward. And you can see it's cutting under that other convection, triggering new storms there around the West Palm Beach area. And then as we lose daylight, you can see it right there approaching, I don't know, I'm not exactly sure how far up and down the coast that is. Somewhere around West Palm Beach, I'm sure Ryan can tell us. Temperatures in the mid-90s there. In Florida, steamy, hot conditions going on. We've got Rat there in Tucson reporting 106. Very hot day there in the southwest. Fred Reamer thinks the Bismarck storms are similar to June 10th, 2010. So yeah, very good analogy there. Eddie Holmes, Western Tennessee, low of 59, high of 85. They got some very dry air in there a few days ago. Got Thomas Copeland here, Brett Dean, 69 degrees. Front pushing through southern Jersey. Michelle Curlin enjoying the June gloomy late afternoon sunshine. Justin Pulliam likes the potential temperature, and we're going to use more of that, certainly, especially with these weak boundaries. Best Weather PT reporting this year is going to continue weird. El Nino shifting towards Nino setup. Rapid change in the sea surface temperature patterns. Yeah, I do kind of wonder what the sea surface temperatures are going to be looking like as we get into July. The Colorado State forecast had an above average hurricane year coming up here. So we're definitely going to cover that if we have another big storm making landfall. We'll do what we did there with Harvey. And yeah, we covered Irma. Had Tim Marshall on the line while he was right there near the eye. That was a lot of fun. Okay, just wrapping up the rest of the chat very briefly. Fred Reamer said, Vivian, South Dakota has the hailstone record now. Does the Weather Service publish a 1,000 through 500 millibar thickness chart? Yeah, sort of, on their GFS products. They've been dropping a lot of the Difax products over the past 10 years, and you would have to go to MAG, the model guidance page at INSEP, and this is probably where you would have to get that. And that, of course, is always model derived the way they do it, so this would be kind of like the semi-official 1,000 through 500 millibar thickness, and in fact that's what we use every night. So there you go. That's how you get to that. But that's great for looking at weather elsewhere. Like if we want to look at Asia, we can certainly do that. Thickness and isobars is a very good way to rapidly see what's happening. Yeah, let me bring that up here. Asia, there it is. 1,000 through 500 millibar thickness. And this is what it looks like in Asia right now. So we're looking at China. Let me help you get your bearings here. Okay, so there's Japan. And then we have China right there. Down to the south, Vietnam, there's India, this is Russia, Mongolia, and Korea right there. So where are the fronts? Well, high pressure over Mongolia, so that's probably going to be some cold air. You can kind of see the thermal troughing in that area, and then it looks like a gradient right there in northern China. So that's going to be a cold front. Probably a little bit of a warm front there. And we're getting into June. This is where the monsoon is typically found, right here in southern Japan, around Okinawa. And that monsoon tends to move northward into the area just south of Beijing and South Korea as we get into July. So that kind of drifts northward, and by August we find the monsoon pattern up here. So that's kind of what goes on there, and the only other thing to look at is up there in Russia. Very strong surface system just east of Moscow. And, of course, that's moving eastward there. Definitely a lot more to look at during the winter. Okay, I think we'll go ahead and get into our forecast. Okay, starting out, we're going to look at the high-resolution rapid refresh, and we'll begin with Texas, and there's that area of convection around the Childress area. Looks like the model initialized pretty well, and you can see that the trend is to move that down towards the moisture in the Abilene area around 1 a.m., and then the thunderstorms fall apart. So very little support there in the upper levels. We're underneath this big ridge. Let's check out the northern plains. That's where SPC, I think they have a slight risk up in that area. And we see a pretty large low there in the Rapid City area. Frontal boundaries up to the north, like that right there. And we're looking at that upper level energy tracking right around the Bismarck area. So you can see how that progresses. kind of an elevated cluster around the Rapid City area. Then as we get up to about 11 o'clock, you can see these cells start lighting up there around the Bismarck area. And there will be a little bit of a window there. Let me show you just ahead of the storms what the air mass looks like. And this is going to be right around 10 or 11 p.m. So yeah, look at that shear right there, 0 through 1 kilometer. 0 through 2 kilometer shear is also pretty good. So the storm motion vector is going to be right in that area. That's going to be a lot of storm relative helicity. So if we do get some deep convection, that should give us some rotating storms. However, as we get later in the evening, around 11 o'clock, the effective inflow layer starts lifting off the ground because we start getting that cooling down there near the ground, and you can see it's already starting to become kind of elevated there. So the effective inflow layer is right through here, and that does sweep out a pretty large area. And let's see what it comes up with. Storm relative helicity, 235 to 700, depending on which layer you have. And CAPE, well, most unstable CAPE, that would be elevated storms up at around 2,000. And then the other measures are a little bit lower. So it is going to be kind of a tight squeeze here for getting severe weather, but there is the potential for these cells right around the Bismarck area. And those will move eastward and congeal into this MCS. And it looks like Minneapolis may be getting some storms right around dawn. Okay, what's going to be happening tomorrow? Good way to figure that out is to start during the morning hours. No, we'll start at the midday hours. Let's do that. Okay, it'll be looking like this. Low pressure there in eastern Colorado. That's the dominant feature. Another low around the Yankton area. There's another low up there in Ontario. And then we've got a high pressure area there over Manitoba. Very broad high there over Florida. So what this is showing is we've got a little bit of southerly flow there in Texas. So there's flow off the Gulf. We've got a cold front. Looks like it's been seeking south through Nebraska and South Dakota. And we probably got a warm front like that right there. And it looks like the remains of that MCS are showing up there in Wisconsin, northern Iowa. So the big question is whether things regenerate close to this low in this warm front right there in northern Iowa. And yeah, it looks like they do right there. Northern Iowa, storms go up. We get the storm cluster heading south. And then by midnight, it back builds into the Omaha area. So it looks like kind of a stormy pattern coming up for tomorrow and tomorrow night. Western Iowa and eastern North Dakota. And there may be some chase prospects in that area. So overnight, that cluster is going to lay down boundaries in this area. That's going to be the setup for Thursday. So let's advance into Thursday. MCS has kind of died off, and we've got those boundaries in this area. Looks like a bit of a high there. So I'm thinking maybe Kansas. Looks like things have just kind of shifted south. And we do have that low pressure area right there. We've got the moisture flowing north. So I'd say maybe, yeah, maybe in Kansas may get some stuff going up later in the evening. Okay, so soundings right around the Salina area. I'm going to take a look at what that looks like. Max heating for Thursday. And looks like some very good moisture there. This is upper 60s to low 70s dew points. Very hot temperatures, and that gives us a lifted parcel, LCL somewhere around right there. And then the lifted parcel goes up kind of like that right there. So I do think that there is definitely the potential for storms going up. Look at that Cape there, 5,000. Even the mixed layers up there near 4,800, so it's a very unstable pattern. Hodograph showing a bit of curvature there. The storm motion is off the hodograph, especially off the lower segments right there, where it says 0, 1, and 2. That's the motion vector right there. So storms are going to be very slow moving too. See that motion vector? It's east-southeast at 10 knots. The algorithm there is showing a tornado setup. What's the STP? There's STP there. It's about 2, which is in the lower end of significant tornadoes. Looks like the main contributor is Cape. Cape is a big one. And looks like, yeah, that's probably going to be it right there. Mostly a Cape-driven scenario there. Now, the NAM does not break out anything. See right there? No storms going up. So I would probably check the other models, see if the GFS generates anything. And maybe the Canadian model and the European model. That's what I would do there. However, everything is very dependent on where the boundaries are and how strong that forcing is from those boundaries. Anyway, on the higher planes, where the theta E at higher elevations is more significant, we do get some storms going up in that area. But the closer you get to that ridge down in this area, the less severe the activity is likely to be. Up here, we've got a little bit more jet support for that stuff. Then going into Friday, it looks like an MCS moving there into Illinois. And then for evening, I think it's probably a little bit hard to say what's going to go on. Definitely looks like a return of more storms there in Amarillo. And I can see a boundary right there along Interstate 70. Let's look at a sounding there for a Friday night in the Topeka area. Sometimes it's better to not look at the precipitation on there and see what the soundings show. And yeah, very unstable, plenty of moisture, but it does look like we have a little bit of capping. See those temperatures there at 700 millibars, they're about 12 Celsius. So it could be a good idea to go to the upper levels and pull up the 700 millibar temperatures. So basically I'm showing you guys how to predict thunderstorm possibilities 2 to 3 days out. So let's bring this up to Friday. Now I'm going to give you Thursday so we can kind of compare it. So this is Thursday around peak heating time. We've got the very light orange in that area indicating about 12 Celsius. But you can see there's a lot less capping as you go to the northeast. So wherever that boundary is, wherever the moisture and better convergence is, that's going to be very important. Like if the best convergence is in the Kansas City area, we've got a pretty decent chance of initiation. But it gets a little more iffy as we go west. And it does look like that ridge builds in towards Friday. See that right there? Some very warm air. That's going to be 12 to 13 Celsius over southern Nebraska, and that could interfere with the prospects on Friday. It could keep things kind of shut down in that area. See that ridge axis right there, that thermal ridge? That could keep things kind of shut down there for Friday. And then going into Saturday real quick, well, can't go that far with NAM, but looking out west, big changes coming up. All that cold air right off the west coast, and you can see that coming in there Thursday and Friday. And by the time we get up to Friday, very strong 700 millibar front, located about like that. So this is up at 10,000 feet. So things will be deteriorating out in the Great Basin area and the northwest. A little bit of weather coming up for that region. So that brings us to the GFS. And while we're at it, we can take a look at Nebraska and Kansas for Thursday. There's an overnight MCS right there in northern Kansas. So GFS a little bit more aggressive with that. And then the setup around midday looks like this. It's going for maybe a little bit of upslope flow storms around the Goodland area. So we shall see some very big differences there with the models. And I think as we go further out towards Friday, Saturday, and Sunday, things get even more doubtful. So we're going to kind of focus on the large-scale picture. I'm going to kind of ignore these. That would be a very good idea. Ignore all this and look at the broad-scale lows and highs. Looks like a pretty good thermal low over Colorado right there. High pressure offshore. We've got the moisture coming north. So there will be storm chances. It'll just depend where the boundaries are at that point. And of course I would want to look at the upper level charts and see how strong the upper level ridging is. And out west, very strong cold front coming in. There it is right there, making its way inland on Saturday. And then for Sunday, wow, look at that strong gradient out west. This is going to be a big weather maker there. Big changes, Boise for Saturday. Reno, Sacramento, very good cold pool coming in. Look at these 540s showing up on the west coast. When we see 540 decameter thickness, that's usually a rain-snow transition. So it's going to be very cold there in Portland and Seattle. Anyway, that cold air makes its way eastward. There it is on Sunday midday. Look at that snow in the higher elevations there, Idaho. That could be all the way down to maybe 4,000 to 5,000 feet, actually. Then as we go into Monday, there's that cold air coming in. This is going to be a very interesting system. We'll keep track of that there. And then up here we have, looks like a second system. I don't think that's an occlusion. I think that's a second system up there in Alberta. So things will be becoming more dynamic, and with that very cold air, that's going to set up a jet, polar front jet, running something like that. So storm chances should be going up for Monday in the northern plains out in this area right here. And then as this continues moving east, that area will shift down into the central plains. So there it is right there for Tuesday. So most of that system will be heading into the northern plains and the Midwest. And down in Texas, we'll just kind of get the tail end of that. So it's good. I mean, at least we'll have some boundaries being kicked down into Kansas, Oklahoma, and Texas. We're not going to be totally shut down for next week. And wow, look up north, a very wound up spider web of isobars. This is definitely an occlusion. Let me back this up, and you can kind of see how that happened. So I'm backing that up. And okay, yeah, that's this low right here. It's basically occluding and moving up the boundary. So here it is. You can see it moving north, and then it gets carried northward, and then we get that occlusion. See it wrapping up here, and then it just kind of flounders around up there in Saskatchewan and Manitoba. So it'll be pretty cold and cloudy and dreary up in Manitoba and Saskatchewan, and down south we'll have those boundaries to work with. And then going later into the period, later next week, lots of storms there in Kansas. And looks like another push of cold air coming southward. So we're not going to be totally out of spring. I think we may pull things together and maybe have some shots of severe weather getting into mid-June. And wow, look at that, another tropical system out in the Gulf. This particular run bringing it up into the Tallahassee area, but I'm sure by tomorrow we're going to be looking at a different solution for that. Another push of cold air coming southeast for the 17th. Yeah, we're looking at an active weather pattern. Another last desperate push of cold air before July starts approaching here. And that's the last frame there for the 21st, and yeah, more cold air coming in from Montana. So we'll see how that pans out. And the Gulf looks like it's wide open. All right, let me check in on chat, see how things are going there. Skew-t analysis for Europe, why not? Yeah, we'll take a quick look at that. Ryan sent me the sea surface temperature. I appreciate that. I'm a little bit behind on email because of that trip there, but I will get caught up. Tim Vasquez on Weather Brains with James Spann. Yeah, we did that a couple weeks ago, and thank you, Brett Dean. I'm glad you enjoyed that, and we'll probably be back on there maybe during an active weather pattern, maybe this fall or next spring. we'll be doing more stuff with those guys. Only 2 likes? Are you kidding me? Let's see, where are the likes? I don't think I can see them. Well, yeah, I mean, if please, yeah, definitely like. That does help out the channel. Okay, 13 likes. That's much better. And yeah, that's pretty important there because likes and all that, that counts as an interaction on YouTube, and that helps push our stream into the search on YouTube for weather. So it's much appreciated there. Okay, yeah, we'll take a quick look at Europe. In fact, let me just set you up with the surface chart. Oh yeah, we can't look at the NEM. I'm trying to pull up something that's not going to pull up too many frames. I don't want to kill the stream. I'm going to look at the I'm going to pull up the GDPS, the Canadian model, and switch over to Europe. So let's go across the pond. European weather segment. Let's see how this goes. All right, so yeah, there's our maps there. Starting out right now, this is how we read things. I haven't looked at European weather in quite some time. All right, what I see here is high pressure across Poland. There's a big high right there. I see lots of cold air across Finland, Karelia, Lithuania, northwest Russia. This is a big cold air mass in that region right there. And then down in France, Germany, I see a little bit of warm air kind of in this area. It's kind of a thermal ridge extending up from Italy up to France there. So with that thermal ridge and lots of moisture, some storms. So a quick look at the forecast. Let's see, low pressure developing there in France. Very weak low there, and I don't really see where the gradient is. That low is just kind of embedded there in the thermal ridge. It's kind of like a little, almost like a tropical depression type system spinning around there. Anyway, yeah, I think I can probably pick out the front because there's that high there. We're definitely going to find that front on the southern end, and there it is. And I guess that extends somewhat like that, and that would probably be a focus for thunderstorms there in eastern France. So let's see, we can't get forecast skew-ts. We'll have to switch over to University of Wyoming. And let's do that. Switch over to Europe. And we'll click on Paris. So this has got to be the only place on YouTube where you can view a Paris sounding. Alright, so there it is. Paris taken just 1 hour ago. Looks very tropical. And we can see that problem there with evaporation of the sensor as it leaves the clouds. So it looks like clouds extending all the way up to about 14,000 feet. Looks overcast in that area. There's probably some storms around the area. This is probably convective debris, and we can see that the flow is out of the east. Very light easterly winds. And let's try to lift that parcel. We've got to keep in mind this is midnight, so we're going to lift this with maybe 73, 74 degree temperatures. It's about as good as I can do. And it does look mildly unstable. So you get a little bit of heating there, thunderstorms going up, and then they tend to shut down at nighttime. And I'll do one more for around the Birmingham area of UK. So this is going to be up there in, let's see, which one is this? Nottingham. Temperature's pretty cool there, 50 degrees at the surface. Looks like maybe a bit of cold air settled over that region. There's the top of the cold air mass up at about 5,000 feet. Some very warm air above that. The tropopause kind of high up at about 40,000 feet. And lots of cloud layers from about 15,000 up to 25,000. So it looks like lots of cirrus covering that area. Very weak wind flow in that region. And this is not conducive to thunderstorms. As you can see here, if we warm up to 70, we'll warm it up to about 68 degrees. The moisture is very shallow, lots of dry air above about 2,000 feet. So if we mix that, we're going to get something like that. And there's our lifted parcel. That's going to be much, much colder than the environment. So conditions in the UK, very unstable. It's just kind of mild and cloudy in that area. Okay, one last check of North Dakota. Let's see what's going on there. It's like a few elevated showers going up in that region. There they are right there, out around the Glen Ullin, Almont, and New Salem area. And I would expect some of these to become somewhat surface-based as they get into the Bismarck area. And that's what's going on up there in farming country. And I think I'm probably about done. I do want to read this comment by Brett Dean. Video changed. People forgot because there were more likes, but YouTube goes by views, not likes. Meaning you can only get paid by YouTube by reaching a certain amount of views, as most of you know. Okay. Yeah, you probably notice I don't run ads. At least I'm not aware of any ads running on the stream because they really pay peanuts. Most of the support is by Patreon, and please drop something in the tip jar. It would be much appreciated. Patreon.com/metlab, and that helps fund the channel and keeps me focused on this program, and allows for equipment upgrades like that drone and the switcher. So yeah, please consider that. Anyway, that's about all I got for tonight. I appreciate you all joining the webcast. We will see you all tomorrow. So take care and have a good evening. Bye-bye.